This video is for lesson 23-4 about solving triangles. Learning goals are to determine when to use the law of sines and when to use the law of cosines, and then to solve problems using those two laws. Question 1 gives us a chart designed to help us determine when to use the law of sines and when to use the law of cosines to solve triangles. And it all depends upon what information you know in terms of the angles, which are the capital letters, and the side lengths, which are the lowercase letters. Now remember for the law of sines that it's a proportion. Over on the left side of the video, let me write just one part of the law of sines. The sine of angle A is to lowercase a, as the sine of angle B is to lowercase b. This could have been written using C instead of one of these letters. But the point is, when you use the law of sines, you have to know three of these things so that only one of them is missing. So if we had a situation where we knew two angle measurements and a side measurement, could we use the law of sines? Well, yes, we could. That would be like knowing this angle and one of the sides, and then you'd have only one missing letter. So this first situation, we would use the law of sines to solve the problem. Now, what if we had another situation and what we knew were two angle measurements and a side? Well, that could still be done with the law of sines because we would know two of the capital letters and one of the lowercase letters, and we could find the other lowercase letter. What if we had a situation where we knew two of the sides and one of the angles? Could we use the law of sines? Yes, we could. What if we had a situation where we knew two sides and we knew the angle in between the sides? In that case, we would have to use the law of cosines to get the answer because we don't have the right information for the law of sines proportion to work. Finally, if we knew numbers on all the sides but didn't know any angles at all, we would have to use the law of cosines. So when you're working with triangles that are not right triangles and you want to use trigonometry to find sides or angles, you use the law of sines or the law of cosines, and you might find that this chart is helpful in determining which one to choose. Let's try one of these. Problem 2. Fire spotters are located at stations B and C, and they see a fire here at location A in the forest. Solve the triangle. Solving a triangle means figuring out all the unknown parts. So in this situation, we don't know side C. We do know side B and side A. We also need to solve for angle A and angle B, but we do already know angle C. So as a starting point, should we use the law of sines or the law of cosines? Well, try to use the law of sines first because it is the easier one to use. To do the law of sines, you have to know both the angle and the side length for one of the letters of the alphabet. Do we know that? No, we don't. So you have to use the law of cosines. I'm going to choose the third version of the law of cosines, the one that goes c squared equals a squared plus b squared minus 2 times a times b times the cosine of capital C. And the reason I'm choosing that version is because I know numbers to put in for every single letter except for one of the letters. The only letter I don't know is lowercase c. So let's make our substitutions. For lowercase a, fill in 12. For lowercase b, it's the 15. And then minus 2 times the 12 times the 15. And then times the cosine of capital C, which is 98 degrees. So we have c squared equals, notice that on the right side of this very long equation, it's just all numbers. We can type that entire thing in the calculator and push enter when we get to the end. That all makes 419. Now do the square root of 419. We find out that lowercase c is 20.4. Now that we know that answer, we could even label it back in our drawing, 20.4. We were asked to solve the triangle, which means find all missing parts. We still need to find capital A and capital B, but we have more information to work with now. And more importantly, we can now use the law of signs to help us get the other ones because we have a number for capital C and lowercase c. So let's do some law of signs work next. Let's focus in on the letter A. We can say sine of capital A is to lowercase a, which is 12, as the sine of capital C, that's 98 degrees, is to lowercase c. See, now notice with the law of signs, you only have one missing variable. Let's solve for capital A. Cross multiplication, 20.4 times the sine of capital A equals 12 times the sine of 98. Then divide both sides by 20.4. We get the sine of capital A equals, and we typed this part in on our calculator. The result is 0.58. Now let's remove the word sine using inverse sine. So we have angle A equals the inverse sine of the 0.58. This is 35.4 degrees. We could go back in our drawing and label that. We're almost done solving the triangle. There's only one letter left that we need to figure out, and that's angle B. Now there's different ways to find that. We could use the law of signs again, but focus on the letter B. Or faster, we could use the angle sum theorem. All three angles of every triangle add to 180, and we already know two of the angles. So to find angle B, we could add it to the 35.4 and the 98 and get 180. 35.4 plus 98 is 133.4. Then subtract the 133.4 from both sides to get B alone. We can go back into our original triangle picture and label that last missing part. Now we've solved the triangle. We figured out angle A in degrees, angle B in degrees, and even side C. Those were the three things that we didn't know at the beginning. To do this, we had to use a combination of all of our triangle skills that we've learned so far. We used trigonometry. We used the fact that all three angles add up to 180. And we even used both of our laws, the law of cosines and the law of sines.